welcome to Wallops Flight Facility, NASA's only owned and operated launch range. I'm Sarah Darty, and I'm excited to introduce you to Wallops and all the exciting missions that we support here on Virginia's Eastern Shore. Come on, let's get started. This is the Range Control Center, otherwise known as the RCC. It's considered the heartbeat of all operations conducted here at Wallops. In these walls, we coordinate and manage an effort by a multitude of scientists, engineers, technicians, project managers, test directors, and others to place rockets where science can be collected. Today, we insert satellites into low Earth orbit, launch a multitude of suborbital sounding rockets, fly unmanned and manned aircraft, and even fly newly designed vehicles. We do this in support of many different partners, such as the Department of Defense, commercial industry, and higher learning institutions. We supported these missions in just the past few years. However, Wallops has a rich history dating back to 1945 with more than 16,000 operations. At the end of World War II, our country realized the importance of developing a national rocketry program, and the government officially opened the gates to Wallops Island on June 27, 1945, conducting its first launch that same day. Through the years, Wallops has grown to be an important national asset as it served as a test location for the Mercury program and began inserting satellites into orbit in 1961. Missions of national importance continue today as Wallops serves as the launch site for International Space Station resupply missions, utilizing a launch vehicle known as Antares. We also support launches for DoD and the Missile Defense Agency, as well as being a test site for unmanned and manned aerial systems. Wallops has facilities for proven and prototype vehicles, which include fabrication and integration. Wallops is also home to NASA's Sounding Rocket Program Office. Sounding rockets are suborbital vehicles designed to place instruments in the upper atmosphere or lower levels of space to conduct a variety of studies. Although we tend to make it look easy, launching rockets can be a difficult business and, if not done properly, can be very dangerous. However, the Wallops team combines the efforts of safety, surveillance, data quality, and a mission assurance team to smooth out the process.
At Wallops, range safety is responsible for protecting the people and property from all of the hazards associated with that particular operation. As the range safety officer, I lead the team that is covering both flight and ground operations. During the countdown, as the RSO, I monitor all of our assets and I give the safety go, no-go call. At any time, I could stop a countdown should the conditions warrant. And that includes things like ships or airplanes moving inside some of our hazard areas. After liftoff, the RSO monitors the in-flight vehicle performance of the vehicle against mission rules and flight safety criteria. And for our larger rockets, that responsibility also includes making a determination as how is that vehicle performing. And I'm pre-authorized to take a destruct action by sending functions to that vehicle before it would ever hazard the public.
The primary function of the surveillance room is to find all of the targets of interest within a prescribed hazard area that range safety deems desirable. So that means that we're looking for boats and aircraft that may be in a particular location that could compromise a launch or compromise their safety. So we use a variety of assets to accomplish the overall surveillance and to give us a good picture as to what we're encountering out in the prescribed hazard areas. And we use both marine assets, boats of various types, and we use air assets, the different aircraft, and they're all equipped with different sensors and data collecting and communication systems that we use to effectively manage the targets that we encounter within a prescribed hazard area.
The data quality room is designed for three main functions: to provide vehicle tracking data for all downrange tracking sources, to verify the quality of that data, and then to make the data available for all of the range users at Wallops Flight Facility. We have a few high-tech systems that our operators utilize, which are the Mission Graphics and the RADAC, which stands for the Range Acquisitions Computer. These systems take the real-time radar data as well as the downlink data, and it converges it into positional data, which allows us to understand and know where the vehicle is at all times, We then take this data and push it over to the Range Control Center so everybody can see it, and also we can have NASA Range Safety use it as well. The days leading up to a mission are full of excitement here in the data control room. Our data control operators are busy running a lot of flight simulations to ensure all of the trajectories are working properly and that we are receiving all of the radar and telemetry data needed for the launch. During a launch, our data quality operators take all of the information that's coming in from our radar and telemetry sites, they ensure it's accurate, and then they send the best sources over to NASA Range Safety, as well as the users and anybody else on this range who requests the information for the launch.
SMART is an acronym that stands for Systems for Mission Awareness in Real Time. The SMART Room is an area in the Range Control Center that is used by software engineers to demonstrate new range data systems while they are in development and test phase. This room was used to demonstrate a potential range data display system during the last Minotaur launch. We'll use this room in the near future to demonstrate Vertex, which is a software application that will provide visualization in real time.
There are many people who take part in an operation at Wallops, but it's not limited to personnel at the facility. Almost every project has a principal investigator or experimenter who is our customer and who is extremely interested in the success of a mission.
The Wallops Range Control Center does a great job of helping us enable students to fly payloads into space. We come here every year with the hope and expectation that students are going to get their payloads into space, and every year Wallops, without fail, has been able to do that. The team you have reaches the students in ways that only Wallops and NASA can. No one else can launch these payloads for students, and knowing that having that reliability every year we come helps us have that program. With the Rock On program, the Rock Sat programs, students build payloads, some of them all year long, with that hope and expectation of getting it into space. And never for a moment do we worry about it not getting there, thanks to the folks here with your Range Control Center. The surveillance systems, the team that puts this whole effort on does an amazing job for us. And without that, we could not do what we do.
As you can see, the RCC is a flurry of activity during a launch countdown. But before a vehicle can take flight, many support services need to be combined into one cohesive team. Wallops employs a stable of test directors and project managers to complete such a task.
As the NASA test director, I lead an effort to obtain the necessary range clearances through the Navy, Federal Aviation Administration, U.S. Coast Guard, NASA Safety, and other organizations, and work with the launch customer to develop a time frame in which to conduct their mission. On launch day, this RCC environment allows me to communicate with all team members at a moment's notice to safely and successfully conduct the mission. It's also my responsibility to ensure all teams have met certain mission criteria and to lead our team to a successful outcome. Other than the launch pad, the Range Control Center is where it all happens. Teams from the launch vehicle, payload, NASA safety, radar, telemetry, and other range services come together in this environment.
As a NASA project manager, the RCC environment allows me to communicate with my team at a moment's notice. Station checks are completed, data flow tests are conducted, potential problems are reported, investigated, and eventually resolved, and a variety of other checks are performed and reported. Literally hundreds or even thousands of simultaneous checks are conducted during the countdown to ensure that we have a successful mission. Before arriving in the RCC for the launch, my team and I have spent months preparing for the mission, analyzing trajectories and vehicle safety data, conducting hazardous operations and preparing the vehicle to be ready to launch, and ensuring all range radar, telemetry, and supporting systems are ready to go. We rehearse the launch until we're a well-oiled machine.
Rocketry is only one part of the Wallops flight arsenal. Currently, unmanned aerial systems technology is taking off, and potential flyers have an increasing need for dedicated airspace to operate their platforms. In 2014, the Federal Aviation Administration named the Mid-Atlantic Aviation Partnership as one of 6 test sites around the country. Led by Virginia Tech University, Wallops serves as a test site for this partnership. One of the more unique abilities of the Wallops range is its mobility. Wallops has a plethora of mobile assets to set up a range literally anywhere around the globe. Mobile telemetry vans, radar antennas, command and control assets, and other support equipment can be sent at a moment's notice to anywhere around the globe. Wallops teams have set up mobile ranges in places such as the South Pacific, Australia, Andoya Rocket Range and Svalbard in Norway, Bermuda, Coquina, North Carolina, and other locations. The Wallops Range is dedicated to enabling the collection of science no matter where the science is located. So that was a quick view of the Range Control Center and how it plays a vital role in all the operations at Wallops Flight Facility. There's much more, so keep in touch with us by checking out our website, visiting us on Facebook, or even stopping by our visitor center located right near the main base. So the next time you see a rocket soaring through the sky or wonder how we're reaching farther for science and technology, think of us right here at Wallops. We're making it happen.